Okay, in this example, we're going to simplify. Notice these two. We have one rational expression multiplied with another rational expression. Yeah, fractions with x's. So what this really boils down to is an exercise in factoring. All we want to do is factor each part, and then you cancel what's the same in the top and bottom. So, to factor this, I got to factor out the greatest common factor. The greatest common factor is x. When I factor x out, I get x squared minus 1. I guess I could factor x squared as x times x. It doesn't matter. I'll factor it. Here, again, I can factor out an x, the greatest common factor, and then I'm left with x plus 2. Here, well, this is a trinomial. The number in front of x squared is 1. So we need to figure out what two numbers multiply to 2 but add to 3. Well, those two numbers are 2, positive 2, and positive 1 multiply to 2, but those two numbers add to 3. Now before I cancel, let me go one step further. This can factor more. This is the difference of two squares. Yeah? So let me factor that a little more and then we'll cancel. So we get x. This is the difference of two squares, so this factors to x plus 1, x minus 1. Then we have x times x. Here we have x times x plus 2. And let me just rewrite that, x plus 2 times x plus 1. Now all we do is cancel. Keep in mind when you multiply fractions, like we studied in Algebra Part 1, you just multiply the top and you multiply the bottom. So after we multiply these, we really end up with one big fraction. Yeah? And so that means all you do, you don't really need to multiply them. Just cancel what's in the top and bottom. This x cancels with one of these. This x cancels with this x. There's an x plus 1 in the top and there's an x plus 1 in the bottom. They cancel. And there's an x plus 2 in the top and there's an x plus 2 in the bottom. So what are we left with? We're left with x minus 1 over 1. Keep in mind when you cancel, there's really all these 1's left. So you're left with x minus 1 over 1, which is x minus 1. So this whole thing here simplifies to a very simple expression, just x minus 1. So in other words, if I wanted to evaluate this for, let's say, an x value of 5, look at how complicated it would be. It'd take a long time. It's very easy. Here, when I plug in 5, I get 5 minus 1 is 4. That's the answer. To believe me, plug in 5 here for everywhere there's an x. Simplify, and after you simplify that, you're going to see it's equal to 4. So that's the purpose of simplifying, to make things simpler or easy.